Alright, so in this video we're going to be talking about radicals. Radicals are just the inverse of exponents. So just like addition is the inverse of subtraction and multiplication and division are inverse operations of each other, radicals are the inverse of exponents. So we have right here some exponents that we should know. 2 to the power of 2 is 4, 3 squared is 9, 4 squared is 16. But radicals ask the question, what if we are just given this number and are trying to find what number multiplies to itself to get us to that number? So because 4 times 4 is 16, what if we start with 16 and then ask ourselves what number multiplies 2 times to get us to 16? And that's all this radical sign is asking. This is asking what number multiplies to itself to get us to 4. Well, we know it's 2. What number multiplies by itself to get us to 9? We know 3 times 3 is 9. And the same thing with 4 times 4 is 16. Alright, so I'm going to go over what a perfect square is. A perfect square is when you square a whole number and you get another whole number in return. So when you square 5, you get 25. And thus 25 is a perfect square, because when you square root it, you get back to that original whole number 5. You can think of this visually in terms of geometry. Like, let's say you had some kind of a quadrilateral and both sides were the same exact length. Well then, when you drew it all out, you'd understand that you got, a perfect square. So it's just this part in between, when you multiply these two, which would get you to 16, that's the perfect square. But not all numbers are perfect squares, right? Like 50 isn't a perfect square, and we know it's not because 49 is a perfect square, so one number above that wouldn't be another perfect square. So what do we do when we're trying to take the square root of a number that isn't a perfect square, though? It's not going to get us a whole number. It'll get us a number and then a bunch of decimals, or maybe a couple decimals or something. So what you're going to want to do is, instead of having a perfect square, you're going to want to try to get factors of this number that are perfect squares. And you can only do this if this number isn't prime, because if it is prime, then obviously we know that it doesn't have any factors other than itself and 1, like 17. We can just leave this here because it's a prime number, so we're not going to be able to break it down or simplify it more. But with 50, we're trying to look for factors of 50 that are perfect squares. So if we go in here and look for factors of 50, we know that 2 times 25 is 50. So the cool thing with radicals is that this can be broken up into rad 25 times rad 2. Or like them both under the same radical sign, or something like that. As long as you're multiplying. This can't be like rad 25, plus 2, because that would be 27, so we can't do that. But right now, we've broken this up into radical 25 times rad 2 is equal to rad 50. And we know we can simplify this radical, right? Because rad 25 is going to get us equal to 5. So this simplifies to 5, and then we're just left with the rad 2. And whenever you have a whole number times a radical, you always want to put the whole number first, and then just the radical right after, and that signifies that you're multiplying them together, which you are. So rad 50 can be actually simplified into 5 rad 2, and that this, when you plug it into your calculator, it gives you the exact same answer as rad 50, because we just split it up into its components, into its factors, simplified one of them, and then kept the other one. So we didn't actually do anything to change the original expression, we just simplified it. Okay, we're going to do the same thing with 125. Again, looking into the numbers here, what factors are hopefully perfect squares? And sometimes you can't just think of a perfect square that's a factor of one of these off the top of your head. You have to just break them down, like we know 125 is divisible by 5. Or we know that 24 is divisible by 2. Maybe we don't have a perfect square off the top of our head, but then we have to keep trying to, simplify until we realize that a perfect square goes into it. So 125, we know that 5 goes into it. So this can be rewritten as 5 times 25. And then, if this makes it any easier, it can be rewritten as rad 5 times rad 25, and then they're kind of separate. Because now you can see that, oh, rad 25 is actually equal to 5, and then you just keep this other one. And that's all it is. This rad 125 simplifies to 5 rad 5. Okay, now let's say we're trying to figure out the square root of 24, but we can't really think of any perfect squares that go into it just right away. But we can think that, okay, we know 24 is divisible by 2, so let's just do that first, right? We have 2 times 12 is equal to 24. Well, let's try breaking up this 12 more. Maybe there's a perfect square in that. But we're thinking of the factors of 12, and we can only kind of think that 2 goes into 12. So we have 2 times, and then this 12 breaks down into 2 times 6. So right now, we have that rad 24 is equal to rad 2 times 2 times 6. This 2 times 2 here, that's just a perfect square, right? 2 squared is equal to 2 times 2. So really, in reality right here, you can kind of think of it as a radical 2 times 2, or rad 4 if you actually multiply together, times rad 6. And we know that rad 4 is a perfect square because it's just 2 times 2. So basically, when you are breaking down the radical and you come across something like this, where you have pairs of numbers inside the radical, automatically that means that you can kind of take it out of the radical, simplify it, and you're going to get 2 rad 6. And yeah, that's basically it. Try to look for these pairs of numbers here. If you can't just think, okay, 4 times 6, square root of 4 is 2, and then you keep the rad 6 because you can't simplify it anymore. Sometimes you just have to go step by step, and that's totally fine. Okay, we're going to do 2 more. So, rad 8. We're going to try to look for numbers that multiply to 8. And 4 times 2 immediately comes up for me. So 4 times 2 is 8. Again, we know that 4 is a perfect square. This is rad 4 times rad 2, and we know that rad 4 is equal to 2, so this is just going to be 2 rad 2. And if you want, you can do this kind of a different way. It's really the same way, but you can kind of look at it differently. This 4 can be broken up into 2 times 2 again, right? So this can really be equal to 2 times 2 times 2. And then you can take out the pair of numbers again, because we know this is just 4, so we know the square root of that is going to be 2, and then you're still left with this other 2 inside. So it's the same answer either way, just different ways of looking at it. Okay, this is radical 39. And rad 39, I don't know why I keep saying radical, but rad 39. The only number that I can really think of that goes into 39 off the top of my head is 3, because it would be 3 times 13. So I can think, okay, 3 times 13 is rad 39. And I'm looking at my list of perfect squares, and I don't really see any that match up with these. And I also know that I can't divide 3 by anything else other than itself and 1 and get a number. Same thing with 13. So these are both prime numbers, meaning if this doesn't break down into anything else, there's no perfect square factors, then we can just leave this number like this, and we can't simplify it anymore like we could with these other numbers.